Okay guys, today I'm going to evaluate these limits. Yeah, there's no way here. Perhaps we are going to use this L'Hopital's rule. If you like it, yeah, it's your lucky day. So okay, let's go. Here I put limit as x approach 0 from the right, yeah, this is equal to x to the power x is equal, like writing this x e to the power of ln of x to the power of x. This is here inside of ln. It's a property, as the base is above equal here, so we can do like that. Next, this is when x approaches 0 from the right, so we get this x can come here in front, so we get x ln of x here, right? From now on, I want to apply L'Hopital's rule here, but without doing many calculus, because to differentiate this from the beginning, it won't help you. I tell you, it won't help you. So here we get, and in fact, this limit can come here as exponent here. Here we can let this to the power of this limit, right? And then I'll put ln of x over x. I don't know whether are we together right now. If you take these, it's the same thing like this. It will x will be multiplying by with ln of x. So here get e. Now we can apply his L'Hopital's rule. If we differentiate, don't forget, we differentiate the numerator here. What we get? We get 1 over x, and we differentiate the denominator, we get minus 1 over x squared. And of course here, what we'll get here, we get this. If you do some operations here, what we get minus x here. Yeah, it's minus x. And then if you plug in the 0, you get minus 0, and it's still 0, and it's 1. So yeah, this is done. So let's go for the next one. This limit as x approaches 0, here we get x to the power of x to the power of x minus 1. First, don't cry, relax, and enjoy my video. So get this x to both x of x no, I will not put minus. Put minus. Yeah, I put minus. This, yeah, it's 1, right? I just wanted to separate the limits, it's one of the limits properties. Now I know this is will give us 1, so it's minus 1 plus this limit here that I want to evaluate. Then I'll do the same thing as I did. It's the same procedure that I've just done for the previous limit here. So I get this ln x. Wait, so this is minus 1 plus, yeah, I'll still keep this limit here, so we get x to the power of x times ln of x. Good. Then yeah, what I'm going to do now, I can take this limit, I can take to the exponent there, there's no problem. So we get e to the power of this limit, I get x ln of x. Now this limit, now there's a relationship between this exercise and the previous one, is that this limit we already know, but let me put this to be obvious. So times this limit ln of x, right? So it's one of the properties, and these you already know the answer. Is what we have just evaluated, that will give us 1. So I can come here, minus 1 plus e to the power of 1, and now this limit, I don't know what I put. No, I won't put. When you sketch the graph of ln of x, it's something like this. So when x approaches 0 from the right, you see a tendency here that it will go to, yeah, it will approach, I don't know, yeah, it will approach to minus infinity. It approach to minus infinity, you know. So this integral, this limit, I mean, it will be minus infinity. So you get minus 1 plus e to the power of minus infinity, and here I get minus 1 plus e plus 1 over e to the power of infinity, and this will give us 0. So the limit is equal to minus 1.